All right, so today's stuff, just so that you guys know what we're going to look at circles. Okay? Just so that you guys know, the biggest thing with circles that we're going to do for you, we're going to keep it kind of simple for you guys. But the circle formulas for you is going to be this. It's x squared plus y squared equals r squared. Okay? What do you think r stands for?
Radius.
The radius, not the diameter. So if they give you a diameter, you'd have to do what? Divide it by 2 in order to get the radius. Okay, so just so that you are aware of it, that's the formula we are going to use. Now, when you get into college, just so that you guys know, it'll look more like this. X minus h squared plus y minus k squared equals r squared. I'm not going to give you any that do that, but what the one that has the h and the k does is it shifts the center in different locations. And it's actually not too bad. The one that we're going to use, the center will always be at 0, 0. The center will be at the origin. So I don't know if you guys noticed that yesterday, but the vertex was always at the origin for those. Just like this, the center will always be at the origin. Okay? The one that's up in the far right-hand corner, that one would be if the center was somewhere else other than the origin. But I'm not going to give you any like that. Okay? So here's what we're going to do first. The first thing that you're going to look at is you're going to look at graphing these. So if I have x squared plus y squared equals, Lindsay, give me a number. 4. Okay? That's what it's going to ask you to do, is it's going to ask you to graph it. Now, what I would do if I were you is I would also identify what the radius is. Now, again, the formula that we're basing this off of is x squared plus y squared equals r squared. So the radius, in order to get that, what you'd have to do is these two pieces, the x squareds and the y squareds, all match. But r squared equals 4 would be what you'd have to figure out for the radius. So even though this is what really is happening, you basically square root that number, and that's your radius. Okay? So what's the square root of 4? 2. Now, in algebra, if we are using or getting rid of square by square rooting, a lot of times we put plus or minus 2. But in this particular instance, it would just be the positive side of it. Does anybody know why? Because it's a circle, and a radius is a... Anybody know? It's a distance. Can distances be negative? No. So therefore, that's why it's always just the positive side of it. All right? So now, as far as graphing it goes, here's what you do. I'm going to see if I can put graph paper over top of it. So 0, 0 would go right here. That's my center. And my radius would be over 2 this way, 2 this way, 2 that way, and 2 that way. What do you think I'm going to do with all those pieces? Connect them. Not with straight lines, in a circular pattern. Kind of like that.
That looks like
Look how good my circle is. I cheated. Okay? So then you draw your circle. Does that make sense? For the first one? Okay, now, if they give you something like this, where it was, let's say it's 2x squared plus 2y squared equals 50. The problem is, I've got 2's in front of my x squared and my y squared. If you notice, I did not put any letters in front of the x squared and the y squared to begin with. And if there is numbers there, I have to do what? Divide them all by 2. Right. I have to divide everything by 2 in order to get it to make it look like the way I want it. When I do that, I get x squared plus y squared equals 25. So what's the radius? 5. Quick question for you. Are they always going to work out perfectly? No. They did for these two, but the radii are not always going to be perfect whole numbers. So when you go to graph that, let's say the radius would have been like 4.7. and you go over 4 and a little more. Not quite to 5, but a little bit as close to it as possible. Okay? So for this particular thing, again, your center is at where? It's at 0, 0. Or the origin. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then you try to connect them as best you can, which is horrible. Okay? But it could be worse. I've seen worse. I've seen people make basically sideways squares out of them. Okay? So just basically what I do is I try to extend that radius just a little bit and then just kind of try to arc it as best as possible to make it look circular. Okay? How you guys feel about graphing? All right? Then, the second thing that they're going to do is they're going to ask you to write it in standard form. Here's what they're going to give you. They're going to give you a radius of, Zane, would you give me a radius? 4. And they want you to write the equation. The equation, again, in standard form is x squared plus y squared equals r squared. Zane just gave us an r of 4. So it's x squared plus y squared equals 4 squared. But what's 4 squared? 16. X squared plus y squared equals 16. Done. Okay? Now, just so that you can see another one that may happen like this. What if they give you a radius of 2 root 5? Is that a possibility? Absolutely. So for this particular thing, again, it's x squared plus y squared equals r squared. Now the key to this one, when you have a number outside of the root, like that, you have to square the outside number, and you have to square the root number, and once you get their answers, multiply them together. So what's 2 squared?
4.
4. What's the square root of 5 squared?
5.
5. What's 4 times 5? 20. So again, here's what happened. When you take 2 root 5 times 2 root 5, these two pieces multiply together first. So what's 2 times 2 again? 4. And then these two multiply together. It's root 5 times root 5, which is the square root of 25. But what's the square root of 25? 5. And it ends up being 4 times 5, and that's how I got to 20. Okay? So again, when you have a root involved, you square the outside number, you square this number, and then once you get for the answers, you multiply them together. Should there be a root left over? No. Not when you're squaring a root. You should not have a root left over. Do you want me to do another one like that? Radius is, Reagan, make up one. Well, not the same one, because then I just will slip it back to that side. Yes, please. 2 root 7. Here, let's even change this up and make that even wackier. 3. You can put whatever you want on it. Now, the other thing, again, remember, it will never be negative, because a radius is a distance. So that will never be a negative number in that spot. If you have a negative number for the radius, you screwed up. Okay? So now, x squared plus y squared equals 3 root 7 squared. To clean that all up, again, here's what happens. It's 3 root 7 times 3 root 7. So the first part, what's 3 times 3? 9. Then, what's root 7 times root 7? The square root of 49, which is 7, or some of you guys were telling me. And then to finish it all out, what's 9 times 7? 63. You're done. Okay, what do you think? Not too bad? Then the last part, we'll ask you to do this. It'll say, write the standard form of the equation of the circle that passes through the given point and whose center is the origin. So the center, again, is going to be the origin for all of these. But now, Kendra, would you give me an order pair? 3, 2. So what has to happen here, you guys, is if this was a circle with the center here and 1, 2, 3, 1, 2, I want to know this radius. How are you going to find that? What, Dan? You can use the Pythagorean Theorem, something that you guys learned in geometry, or you could use the distance formula. Well, either one will work. Now, here's how the Pythagorean Theorem comes out of that. Just so that you can see it, I'll put it in a different color. You went over 3 units, then you went up 2 units. Do you see the triangle now? This is a 2, this is a 3, and if you look at the Pythagorean Theorem, again, remember it's a squared plus b squared equals c squared. So what's a in this problem? 3. What's b in this problem? 2. I heard somebody whisper and not want to say it out loud. What's 3 squared? 9. Plus 2 squared? 4. And 9 plus 4 is 13. And if I wrote that to get rid of it, c is the square root of 13. Here's the catch for you, just so that you guys understand this. C in this problem is the exact same thing as the radius of my circle. Okay? So this part right here, if I were to draw a circle, it'd be coming in here like so. That's the radius. So C is the radius. So now x squared, bless you, plus y squared equals the square root of 13 squared. What's the square root of 13 squared? 13. Here's a little quick side note, just see if you guys can figure that part out. Could you, instead of rooting it like we did right there in that step, could you just put that number in for the r squared? Because remember we had c squared equals 13. Could you just take that 13 and put it in for the r squared? Yeah, you could, instead of going through the whole process. So that is an option. The other option would have been use the distance formula, which would have given you the same answer. Okay? Do you want me to do another one like that? No matter what, an ordered pair with the origin is always going to give you that Pythagorean Theorem part. And that's it. That's all that's new for circles. So is everybody comfortable with it? Yeah? Okay.